They have some notice, okay, like I mentioned in this topic, but I will not go over all the codes, okay, because you can easily apply this code to your data. Try to fix some problems, okay? There are some problems, might be some problems before you analyze your data, okay? For example, you might only collect very few data points. So that the n might be less than 100, 200, 300. You would like to train your model, okay? The best case is you have a lot of data. All those data represent your subject, 就是你的目标. So that you can use this data to train your model. You don't want to have only very few data because those data does not have enough representation. 就中文说，如果你资料很少的话，这些资料少到不具有代表性，代表原本的母体的量，所以你在做 training 的时候，你就只能 train 你看过的东西，而不是整个母体的某一个抽样。那这样子的话，你做出来的 model 就不会太好。好，所以第一点是这个。So the first problem might be you only have only very few data. However, the second problem is you have too many data points. So that when you train your model, it takes a long time to train your model, which is not good for you because you have to wait. 好，第二点就是那个 n 值啊，又变得太大了，就是你有太多资料，几千万、几亿笔资料，那你就没有办法赶快把那个 model 算完嘛，因为你那个做那个微分那不得了，那几千万的 data point 那非常麻烦，那就资料太大。So either you have too few data, or you have too many data points. If you have too few data, let's talk about downsampling. If you have too many data points, and you believe that those data points can represent the all population of your data. 就是如果你的资料很多，然后你觉得你大概所有的母体的东西大概都被这些东西 cover 住了 ，then you can simply just do a random sampling. You only use part of your data to construct your model, which is good because you believe the population is represented by your samples. 因为你抽样抽得够好的话嘛，你100万的东西嘛，你就随便抽嘛，你抽个10万的出来，如果你的母体真的很棒的话。对不对？然后你抽样抽得很随机的话，这10万的东西已经代表你的母体，那你就用这个东西来 train 你的 model 就好了嘛，对不对？那就比较简单。Okay, so that's more simple. You just randomly sample your data as your training data points. Okay, but what about upsampling? If you only have very few data, how did you do? Okay, we have some visualized view graph. Okay, so I jump to those things. The first thing is random oversampler. Upsampling, okay? There are some packages, okay, right here. Okay, you can simply just click it or see my example right here. Okay, try to learn how to do upsampling. There are 3 different classes marked as 0, 1, and 2. The data point of the second class has 972 data points, and only 15 data point belongs to class 1, and only 13 of the data point belongs to class 0. So this kind of data is quite unbalanced. So we would like to increase some data point for class 0 and class 1. 因为这个资料相当极度的不平衡嘛，对不对？所以我们就想要增加资料点。那2号的这个就应该是黄色的这些哈，资料点已经够多了，那我们就想要办法增加1号的资料点，或是0号的资料点。好，这跟前面的一样，就是说，如果你的资料点不够的话，你一定会想办法增加那些资料点。Okay? There are several different ways. You can simply just random select data point in class 1 or class 0. There are some data point right here, right? That belongs to purple data point. Okay. So how did you do that? You can calculate the average of this purple data point. For example, the centroid of this purple data point may be right here. And you can randomly select some standard deviation or z value to create even more purple data point around this centroid. 好，就是如果紫色点不够多啊，那很简单，你就把紫色点全部找出来，对不对？然后找到一个中心点，好，然后算一下它的标准差，就是 variance 啊，然后想办法随机，真的随机哦，随机的设一些 z 值。那这些 z 值呢，啊，就是 随机的筛出来，然后你就去把平均值加上 z 倍的标准差，对不对？你可以随机的生出这些资料点，在这个紫色中心点附近。So then maybe, okay, you can do this. So you have this purple point. So then further, when you do SVM, okay, I believe that is SVM, okay. So if you have only very few data points, so you might want to consider to do upsampling. And the most important of all, because you use central A and standard deviation to create a new data, your distribution is still the same. 啊，中文就是说，因为我们比如说随便取一个中心点嘛，然后又维持它的标准差嘛，对不对？然后我们比如说用normal distribution 方式随便去筛一些骰子嘛，对不对？那你这样筛出来的骰子就会在那中心点的周围嘛，对不对？然后它分布的形式应该还是符合，比如说原本的常态分布。所以你虽然那个紫色点原本很少啊，你筛出了很多新的随机的点，可那个点跟原本平均值还是没有变，标准差也没有变，那看起来那个母体的样子好像没有变，但是点变多了，就是随机的这样子啊。那至于说方法是不是只有这种？没有，方法有超多种的，那数学家已经帮我们做好了，所以你就去看有哪一些 upsampling 的方式，有各式各样 upsampling 的方式，那你可以去尝试把那些点选出来。Okay, there are a lot of different packages which developed by some mathematicians, so they will help you to create data points. Okay, that is the first problem. What if we have only very few features? For example, you want to describe a child, but you have only 10 features. That is too few. Because to describe a person, an animal, a product, maybe you need hundreds of features to describe your subject, right? So how did you create even more features? Of course, you can just collect more features. Or you can do feature engineering, which means we can create a new feature is xm plus 1. And this feature is a combination of the features you have. Maybe that is x1 over x2. So you have to be familiar with the subject you are trying to analyze. And maybe you believe x1 over x2 is a new feature, and it's very important to do such kind of analyze. 那因为你假设你的问题3是你没有足够多的 feature 可以用，那你就创造 feature。啊，创造 feature， 要不然你就收集更多 feature， 要不然你就是在原有 feature 上做一些所谓 feature engineering 的事情。那可是这个很吃 domain knowledge。比如说，我们之前在分析房子的时候啊，我们做了一个除法。除法是什么？除法是你比如说你的楼地板面积除以你的房间数好了。那这样这个意思是什么？这个意思大致上就是表示说一个房间有多大，对不对？那你就凭空创造出一个新的 feature 出来啊。所以这没办法，这个 feature 太少，这件事情就很吃 domain knowledge。这个就没有办法，这个只能自己做，这个数学家没有办法帮你的啊。You might use the old features to create new features, something like this. Okay. Problem number 4. What if I have too many features? As we described before, we have a very nice tool, which is right. If you have, so I can do principal component analysis to map the original data to the principal component space, and you choose a k value to keep only maybe 90% of variance or 90% of variance, which is good enough for you to do the further analysis. So you can do PCA, which is dimension reduction. Of course, there are several different methods can be used to do dimension reduction, but principal component analysis is one of the major methods. And if we of course, there are some other methods we will talk about later. For example, it's the same as this one. Okay, we have different targets 0, 1, and 2. However, the data point is unbalanced. Okay, it is exactly the same as upsampling, right? We can target on class 1 or class 0 and do upsampling for this class, so that the data point and in each class will be balanced. For example, 300, 300, 300, right? We do downsampling for class 1, and we do upsampling for class 2 and for class 0 and class 2. So that SVM can do better job later. What else? Sometimes when we collect the data and there's some missing value in your table, it just disappeared. You don't know why. If you have enough features and enough data point, you can simply just remove this one, remove this feature, remove this data point, right? That is a very straightforward strategy to do so. However, sometimes, okay, you have limited features, you have limited data points, so you cannot remove one. There are several different ways to fill some data in this data point. For example, distance. For this data point right here, as we told you before, we can find the other data point among your N data points. We can find the closest one, right? So if these two data points, they are very, very close, they are very, very similar, then I can borrow its value, right? Because the rest of the features, feature 1, feature 3, 4, 5 to feature xn, in that space, okay, without feature x2, these two data points are very, very close. They are very, very similar from the perspective of x1, x3, 4, 5, 6 to n. If that close enough, and I can borrow the x2 value from the other data point to fill in this data, okay? The other approach, there's some other approach like this, okay? Average, standard deviation, right? I can simply just borrow the average of x2 and fill it in this missing cell. It's quite straightforward, right? Or I can simply just randomly select a value in x2 and fill, and so on and so forth. There are a lot of different ways to deal with the missing values. For example, there's a data number 3, okay? It's xn value, which is considered as an outlier. How did you define an outlier? There are several different ways, okay? We have some, I believe we have some notice right here. It's right here. We have several different mathematical tools to help us to define what is an outlier. So that in your data set, you can find, okay, this data point is an outlier. That is because compared with its average and the standard deviation, its z-score is extremely large. 我们有很多方法判断一个资料点是不是 outlier 哈。那这里有就有4个方法，对不对？那这4个方法，其实第一个是说什么？你一个资料栏位一定有平均值跟标准差嘛。好，刚刚那个紫色上面画一个。那 z 值很简单嘛，减掉平均值除以标准差嘛。如果你的 z 值是什么正13啊、负18那种远远超过你在 normal distribution 里面的概念。你知道在 normal distribution 里面，不是好像正3、负3就已经应该要正90几的资料了，对不对？那什么正5啊、正8、正10几啊，那个都已经很远很远了哈，离我们中一点太远了，所以我们可以用 z 值来表示。Okay, so if you have a very large z-score, okay, considering it's a normal distribution, you can simply just consider, okay, this is an outlier. You have another approach, which is Bob plot. Okay, that's another mathematical tools. Okay, IQR, which means your Q3 subtract from Q1. Q3 知道吧 ？Q3 就是75分位数嘛 ，Q 就是25分位数嘛，这边找到2个数值啊，相减就是 IQR。如果你一般来说，我们认为说，如果你 outlier 啊，大概是 Q1 啊加减 K 倍的 IQR， 好，就是如果你 Q1 跟 Q3 有个距离，那你 Q1 往下。或是 Q3 往上差太远了，那 K 可能都是2或3左右吧。其实它跟标准差意思非常的类似，啊，非常类似，就表示说你的资料离你的群中心啊，平均值 Q1、Q3 这个群的中间已经太远了，那我们就视为你是 outlier。Okay, if your data is far away from your average, or Q1, Q3, which is 25% percentile, 75 percentile, it's too far away, then we consider this data point is an outlier, and you should remove this data from your data set. Of course, there are several other ways. If you take a look at this data table, again, there are several different problems you should consider. Take a look at this slide, and there are some examples. Okay, you can just simply read them. And if you want to use, for example, sampling to remove the outlier, to fill in the missing data, you can use some packages, which is quite convenient. Okay, you can use one single function to deal with the missing value, missing data problems, to deal with the sampling up, sampling or downsampling data. Or in Orange, okay, you can use a widget to deal with these things. Try to take a look at this slide. Okay, that we talked something about those problematic data.